So we are trying to understand frequency shifting. Eyes on board please and silence please. We are trying to understand frequency shifting. We have seen the general formula in previous video. Now let's apply that. हमें पता है कि एक x of t अगर 1 होगा, 1 का फोरियर ट्रांसफॉर्म जब हम करते हैं, it is delta. That is a delta function, is an impulse function which is existing at point 0. ठीक? Now, if I say I multiply it by an exponential, कौन सा exponential हमने पहले दिया था? e raised power multiply करेंगे जरा उसको, e raised power j 2 pi f naught t into, can you write the result? Can you write the result please? 1. Excellent. Delta f minus f naught. Now this you don't know, but just see what is happening and accordingly you will do in the future. So my origin signal was at 0. I am getting it shifted by some amount. How much? F. So I will put this to 0. F minus f naught is equal to 0. So my new f will be equal to f naught. That means my negative f over here has shifted the frequency in the positive direction. Do you get my point? Is it clear for every time? I will repeat. देखो जी, जब भी आपको इस इम्पल्स का पॉइंट ढूंढना है, ये इम्पल्स कहाँ एग्जिस्ट करेगा, जो भी यहाँ पे वैल्यू होगा ना ब्रैकेट में, आप उसको पुट करेंगे 0. For this case, f is equal to 0 straight away. So my impulse stays at point 0. For this case, I put this f minus f naught equal to 0. Eyes on board please. I put f minus f naught equal to 0. Therefore f, the point where the impulse will be shifted, happens to be f naught. That is in the positive direction. See? Now maybe this is a slightly different way to remember, but let's go with the next case. Minus j 2 pi f naught t into 1. इसका क्या होगा? Delta of waves. Very good. F plus f naught. इसका जो स्पेक्ट्रम होगा जरा कौन बताएगा मुझे? कौन बताएगा? गलत सुई. जल्दी से इसका स्पेक्ट्रम बनाइए. I believe you can do this. Right? आएगा ना आपको? इसको आएगा वो बना रहा है अपने नोट पे. मैंने मैजिक पूट के इसको ना क्या पूट डाल दिया. ये आपने कैसे निकाला कि माइनस एफ नॉट पे आएगा स्पेक्ट्रम? बोर्ड पर लगता फॉन्ट का इंक्रीज. Is it correct? Yes, sir. Thank you very much. This is absolutely correct. Is that okay? Now, you might be knowing, is this visible? If I have a signal, is this visible?
Yes, sir.
If I have a signal like cos of, or a signal like A into cos of 2 pi fct, अगर मेरे पास एक सिग्नल है A cos 2 pi fct, do you know something about Euler's expansion or Euler's formula? Euler's formula आप अपनी जगह ये भी देखने के ऑप्शनल असाइनमेंट है. वो क्या होता है? I can represent this cos signal in terms of exponents. Okay, I can represent this cos signal in terms of exponents. That is e raised for j theta, but theta happens to be 2 pi f naught plus e raised for minus j 2 pi fc rather here. थोड़ा जंबल हो गया. So okay, I can represent this cos as A रहेगा बाहरी. This cos comes out to be e raised for j 2 pi fc t plus e raised for minus j 2 pi fc t. divided by 2. Now if I just try to rearrange this whole thing, I will have a by 2, I take 2 as common, a by 2 e raised power j 2 pi fct plus e raised power minus j 2 pi fct. By the way, the value of this impulse happens to be 1. Okay, the value of this impulse happens to be 1 because we have nothing multiplied over here. So this is 1, this is 1. This is 1 का जाओ नहीं वापस 1. Okay, what is the value of the amplitude of this? It is 1. So this is the formula. Now can you tell me what is the Fourier transform of this signal? Fourier transform, come on. Fourier transform of this signal is, जो आपके पास ये सिग्नल आ गया, इसका Fourier transform क्या है?
Delta f plus fc plus delta.
No, you just write it. You just write it. So, if we analyze the Heisenberg trees, those who are not able to do, I think maximum of you have done it. So, if I analyze this signal, the expanded version of the cos signal, it is nothing but I have this thing same as this one जो मैंने यहाँ पे लिखा था, and ये वाला part जो उसका transform ये होगा. So let me just rewrite it again, but difference ये रहेगी यहाँ पे a by 2 आएगा. So what I see is that my this signal gets converted into a by 2 delta of f minus fc or f plus fc, f minus fc, okay, plus delta of f plus fc. Now then, I have seen that the spectrum, okay, what is this? This is, remember these keywords, I will tell you to draw the spectrum, you should be able to draw it on your own now. I will not tell it over and over again, this is the spectrum. So, this is the spectrum or the amplitude spectrum. So, when I ask you to draw the spectrum of the signal, the spectrum of f minus f naught looks like something like this. F plus f naught this. If I add these two signals, the net result is nothing but a signal where I will have this impulse and this impulse. But that's not the right way to remember. Let's see it from this. So I have delta of f minus fc. So I will make the spectrum. Is this visible? Yeah, visible is it? Huh?
ये वाली लाइन नहीं इसके बाद.
So let me make this again. अब सवाल है इसका स्पेक्ट्रम कैसे आएगा? I am going back to the top. I have the 0 point. My amplitude is a by 2. That I should remember. Now I have an impulse at what point? F minus fc. F minus fc. But that will result in an impulse in f at point fc. Okay? So because of this, I have this frequency. Now because of this, f plus fc, I will have impulse at amplitude has to be equal for these two. So it will be at minus fc. And now the question, what is the amplitude? The amplitude is nothing but a by 2. So a by 2. Is that okay? This happens to be the spectrum of this signal. Is that okay? You are doing a great job if you understood this. Because you understood the basic point of communication. So next property is Next is modulation property. Modulation property. Modulation property. You write if x of t if x of t is a signal in time domain whose Fourier transform is equal to x of f, whose Fourier transform is equal to capital X of f in frequency domain, whose Fourier transform is capital X of f in frequency domain, that is x of t Fourier transform x of f. ये लिखना है मुझसे. Then if we multiply a cosine signal with this x of t, then if we multiply a cosine signal with this x of t, that is x of t into cos of 2 pi fct but we know that a cosine signal using the Euler's expansion is actually a combination of two exponential So we will now go for the Fourier transform of this signal. The Fourier transform because of this x of t, इससे पहले इसको 1 मल्टीप्लाई था, है ना, 1 मल्टीप्लाई, तो 1 का जो ट्रांसफॉर्म था वो शिफ्ट हो रहा था बाय दिस एक्सपोनेंशियल, लेकिन अब इसको x of t मल्टीप्लाई है, यहाँ भी और eyes are good. Now we have x of t multiplied here and here also. Therefore, the Fourier transform of x of t will be shifted by this exponential. That means if Fourier transform of x of t was x of f, then the Fourier transform of x of t into e raised to j to f ct will be x of f minus f naught jog plus x of f plus f naught whole divided by 2, because 2 will stay. Is that correct? Please tell me yes or no. FC, right? FC is the correct one. So x of t multiplied by exponential will result in shifting the frequency. Yes, it is exactly same like this, but the difference is here we had 1 multiplied by 1. Okay, the x value of x of t equal to 1, and the transform of x of t is delta. How do you know that? 1 is delta. So the transform of 1 is shifted by minus x. Here I have the signal x of t. Its Fourier transform is x of f. The transform of x of t, that is x of f, is shifted by f. Here the delta is shifted by f. Here x of f is shifted. Because delta is the Fourier transform of what? Exactly. X of f is the Fourier transform of. So this becomes a universal formula. Whatever is the nature of signal, its Fourier transform will be shifted by this. That is what is called as a modulation property, or for this modulation property we will move for the understanding of the frequency. So therefore conclusion is Okay, the conclusion is, कंक्लूजन नीचे एक लाइन लिखिए, कंक्लूजन रेड पेन से लिखिए, अंडरलाइन कीजिए, 2-3 डॉट्स उसको डालिए। तो करना क्या है क्लास में, ऐसे बैठ के लिखते जाइए। सो कंक्लूजन इज, if we multiply the original signal by a cosine function, or maybe for that matter by a sine function also, because cosine and sine are actually same. They are, I mean to say the nature of the signal should be such that it contains two exponential signals. So if we but for now we will just keep it as a general formula. So if we multiply the original signal by cosine function, comma, the signal gets modulated. The signal gets, कौन सा सिग्नल मॉड्यूलेट हो जाता है? एक्सो। आपको समझा है? सो आपसे कोई सवाल पूछेगा मॉड्यूलेशन हमें करनी है किसी सिग्नल की, हम क्या कहेंगे? सिंपली एक हाई फ्रीक्वेंसी, अब लेकिन बेहतर ये था मैं यहाँ पे लिखता बाय अ हाई फ्रीक्वेंसी कोसाइन सिग्नल, बाय अ हाई फ्रीक्वेंसी कोसाइन फंक्शन, कोसाइन फंक्शन, बिकॉज कोसाइन फंक्शन में साइन खुद ही आ जाएगा, राइट? सो आई विल रिपीट, इफ यू मल्टीप्लाई द ओरिजिनल सिग्नल बाय अ हाई फ्रीक्वेंसी कोसाइन सिग्नल या कोसाइन फंक्शन, it gets modulated. ठीक? So in order to modulate any signal x of t, we multiply it by a cosine function. But the question to you is, आप बताइए जवाब आप, ठीक है? देख रहे हो मेरी तरफ? मुझे बताइए, सवाल ये है कि हम मॉड्यूलेशन कर क्यों रहे? जवाब आप जवाब बताओ अपने दिमाग में जो है आपके दिमाग में आईपीएल के स्कोर से खाली कि उसके बगैर भी कुछ और रखा है? इस टाइम हाईएस्ट रन स्कोरर कौन है आईपीएल? हाँ, पहले ये जवाब बताओ, आईपीएल में हाईएस्ट रन स्कोरर कौन है? बताइए, फिर क्या पता है आपको? ओके, टेल मी नाउ द आंसर। आप बताइए इसके जो लेफ्ट में, हम मॉड्यूलेशन करते क्यों है? आपके लेफ्ट में जो है, जो राइट ना, बैठ पान लाभ कसर फिटे, हाँ, यू आर करेक्ट, कम ऑन, यू डिड ट्राई, रॉन्ग आंसर। हाँ बताओ, गलत ही जवाब है। हाँ, राइट, वो तो हो गया, वो मॉड्यूलेशन हो गया, बट लेकिन एक सवाल पूछ रहा हूँ, आप बताइए, थोड़ा बैठना, क्या पूछता क्या? To reduce antenna size, this is one. But more than that, what is the actual purpose? Is that we need to transmit this signal through an antenna. We need to send this signal through an antenna to a long distance. So we try to modulate it, and without increasing the frequency, we will not be able to reduce the antenna height. So that's why we are modulating actually. So the जल्दी आप लिखिए नेक्स्ट लाइन, बाय मॉड्यूलेशन। ये एक प्रॉपर नोट होना चाहिए इसके बाद नए से। अभी नोट पे पुराना नोट खत्म हो गया, पुराना नोट नेक्स्ट वाला शुरू कीजिए। बाय मॉड्यूलेशन, the signal is translated from a low frequency region to a high frequency region. By modulation, the signal is translated rather by modulation, the signal is translated from a low frequency region to high frequency region. This is point number 1. इसको point number 1, अगर आपसे कोई पूछेगा मॉड्यूलेशन से होता क्या है एक सिग्नल के नेचर पे, जवाब ये सवाल असली में जिस सवाल का जवाब ये है, वो सवाल ये है कि मॉड्यूलेशन से होता क्या है। तो पहली चीज जो मॉड्यूलेशन से होती है, the signal is translated from a low frequency region to a high frequency region. Point number 2, the baseband signal becomes band pass signal. The baseband signal becomes band pass signal. ये एक ऑप्शनल असाइनमेंट है आपके लिए। ये देखिएगा बेस बैंड सिग्नल क्या है। आपके इंफॉर्मेशन के लिए मैं ये कहूँ, बेस बैंड सिग्नल वो है जिसमें लोअर फ्रीक्वेंसीज होते हैं एंड बैंड पास सिग्नल वो बन जाता है जिसमें एक हायर पर्टिकुलर बैंड ऑफ फ्रीक्वेंसीज होते हैं, लेकिन फिर भी आप अगर देखें तो बेहतर है। ये असाइनमेंट मगर नहीं है, ऑप्शनल असाइनमेंट। बेस बैंड सिग्नल बिकम्स बैंड पास सिग्नल। नेक्स्ट, वाइड बैंड सिग्नल बिकम्स नैरो बैंड सिग्नल। वाइड बैंड सिग्नल बिकम्स नैरो बैंड सिग्नल। एक वाइड बैंड सिग्नल ऐसा होता है, वाइड बैंड सिग्नल shows us a signal. ये then the ratio of highest frequency of the signal divided by lowest frequency is greater and greater and greater than 1. You go wide band. ठीक? So you say narrow band signal. So should it will ratio should take the ratio of highest f divided by lowest frequency. It is approximately equal to 1. This becomes a narrow band signal and above one is a wide band signal. ठीक है? When the ratio of the highest frequency जो होती है divided by the lowest frequency of a particular signal, when that ratio is very very large in 1, then it is called as a wide band signal. Okay. Now I have heard this term now over and over again, modulation, 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 modulation. But if we modulate a signal and we send it from the source towards the destination, write this please very quickly. This is not a big concept. Highest frequency by lowest frequency is 1, wide band. Highest frequency equal to 1, narrow band. Done? So we have heard about this term over and over again, modulation. Jana, I'll call you Jana, not Jana. Okay? Is that okay? I'll call you Jana. Okay. So but you will tune your ear. Jana, not Joanna. Okay? What's your name now? Actually, but what will I say? Jana. The keyword for your ear should be, when I say Jana, you should look towards me. Or I would say John Saba. What? John. The keyword is John. Saba means extra respect. You can confirm that from Moise, okay? Anyways, so when I send a signal, eyes on board please. I am trying to ask you a question. I have the signal. I have modulated it. What do I do after modulation? I send it through an antenna. Antenna से कहाँ जाएगा? I repeat. I modulated a signal. I send the signal through an antenna towards air or free space, and then it reaches the destination. When it reaches the destination, where does it reach? Antenna. Receiving antenna, na? Okay, the receiving antenna takes the signal. Now what should be the first step? Demodulation. What should be the first step? Demodulation. Excellent. So demodulation should be the first step, because a modulated signal is kind of an encoded signal, I would say, for time being, for you to understand. And when I have encoded signal, I need to decode it. Likewise, when I send a modulated signal, I need to demodulate it. So what does demodulation do? So you write demodulation and underline it. Point number 1. It is the process of reconstruction of the message signal. Demodulation is the process of reconstruction of the message signal. Reconstruction of the message. Demodulation is the process, it is the process of reconstruction of message signal from the modulated signal at the receiver side, right? So demodulation will always happen on this side, the receiver side, right? Logical? So demodulation is the process of reconstruction. What do you mean by reconstruction? I would say I reconstruct, extract the message signal from the original modulated signal. My message signal will be inside the modulated signal, okay? So reconstruction of the message signal from the modulated signal. Point number 2. No, that's okay. Because I've said this demodulation will be done at the receiver side only. Okay? Demodulation is done at the receiver side. Point number 3. Based on the number of frequency tones present in the message signal, based on the frequency tones, or I would say number of frequency tones. Number of frequency tones क्या चीज होता है? इसमें कितने कंपोनेंट्स है, इसमें कितनी फ्रीक्वेंसी. लाइक फॉर एग्जांपल प्रीवियस केस में हमने देखा F0 is only one frequency component. Maybe I have F0, F1, F2, F3, F4, so many frequency components that exist. उतने ज़्यादा impulses भी exist करेंगे. So when I have many tones, this type of modulation is known as multitone modulation. I repeat, if I have more frequency tones present in a signal, more than one, it is known as multitone frequency modulation, multitone modulation. While as when I have only a single frequency component, it is known as single tone modulation. Okay, we just complete the sentence. Based on the number of frequency tones present in a message signal, modulation can be classified as single tone modulation. Modulation can be classified as single tone modulation if the frequency component is only one. Modulation can be classified as single tone modulation. Modulation can be classified as single tone modulation if the अगर फ्रीक्वेंसी कंपोनेंट एक ही है तो सिंगल टोन. उसकी एग्जांपल मैथमेटिकली अगर हम समझे तो दैट इज मेरा मैसेज सिग्नल जो है let m of t be the message signal. अभी तक हमने x of t को देखा था, वो एक जनरल सिग्नल था. अब से आइंदा के लिए जब तक हमारा सेमेस्टर खत्म होता है, we will say m of t is the message signal. Okay, m of t is the message signal. So if it is denoted by an expression as a of m is the amplitude of the message signal, cos of, you can write where a of m is the amplitude, cos of, साफ साफ लिखो साइड में नोट्स में, a of m is the, और जब आप आंसर्स भी लिखो ना, where a of m is the message signal amplitude, cos of 2 pi f m t, where f of m is the message signal frequency. Okay, इसका स्पेक्ट्रम कैसा आएगा? So this is the signal, this is the spectrum. स्पेक्ट्रम जो उसका आएगा 0 यहां पे आएगा. कौन सा स्पेक्ट्रम क्यों किया? कॉस सिग्नल है. आई डोंट बोर्ड प्लीज. कॉस सिग्नल है. कॉस सिग्नल जनरेट करता है दो एक्सपोनेंट्स. मल्टीप्लाई x of t कुछ नहीं है, मल्टीप्लाइड बाय 1 है. तो दैट मींस एक होगा fm पे, दूसरा होगा माइनस fm पे. कैसे? ये लेक्चर आप जरूरी कुछ तबला रिवाइज करेंगे, लेकिन आप शॉर्ट टाइम याद रखेंगे कॉस ऐसा स्पेक्ट्रम जनरेट करेगा. ठीक है, लेवल हमारी बढ़ गई है. वी वोंट गो टू एक्सपोनेंशियल नाउ. Next one, if the message signal contains multiple frequencies, if the message signal contains multiple frequencies, if the message signal contains multiple frequencies, जिसको हमने डिनोट किया है से m of कैपिटल m of f से, उसका जो स्पेक्ट्रम होगा वो एक कंटिन्यूअस स्पेक्ट्रम होगा. ओमेगा. एंड इसी तरह से नेगेटिव साइड से भी होगा माइनस, ठीक है। सो दिस इज मोर ऑफ लाइक जिस तरह हमारा वो कंटिन्यूअस वेरिएबल और डिस्क्रीट वेरिएबल कुछ वैसा ही हमें नजर आ रहा है, हालांकि देयर इज नॉट एग्जैक्ट कोरिलेशन, बट आई टेल यू दैट इफ वी हैव अ multitone message signal denoted by m of f, capital M of f, its spectrum will look like something like this. This means that we have so many frequency tones present in this signal, okay? ठीक है, यहाँ पे we have a frequency tone only at one particular point. यहाँ पे हर एक जगह एक एक frequency tone है, उसकी intensity भी different है। इसकी intensity और इसकी intensity same होगी by the way, and इसका value क्या होगा? ना, ये तो cos का है am, इसको जब हम exponential break करेंगे am by 2। बहुत इंपॉर्टेंट पॉइंट याद रखो, अक्सर डायग्राम में गलती हो जाती है, cos के साथ जो वैल्यू उसको डिवाइड बाय 2 हो जाएगा, सुना? क्योंकि जब हम इसका वो ब्रेक करते हैं ना यूलर्स फॉर्मूला से, तो डिवाइड बाय 2 आता है ना, ठीक है। Let's take a break of 2 minutes and let's continue again, 2-3 minutes, but in class only. So this is a general suggestion to every one of you. The engineering degree is actually the beginning of the story. An engineering degree will give you a mindset, a temperament to start something which can be very, very big. Because you can observe this in your communities, within your cousins and all. A person who is doing maybe a different degree, which is non-engineering degree, that can be any respectable degree. That doesn't mean you look towards them, BSc. I don't mean that. What I mean to say is that their approach to problems will be different. You just observe this. Your maybe even twin brother or sister can be different than you if she is reading a different subject. The subject, the theory, the practical actually impacts your mindset. So your approach will always be different. So engineering is actually the beginning, which is equipped with you, with a temperament. The latest technology, the latest trend is actually your job. Maybe teachers here will actually give you a broader concept about the subject, and that is their job. And if they are doing that, I salute them. That is more than enough. If they are giving you a broader perspective of the subject, and obviously they will have to start with those basic concepts. Your syllabus over here generally gets updated. आपका जो So we have talked about modulation, we discussed demodulation, but now let's understand how this modulation actually happens, because that's what we will start with in coming lectures. Some basic terms about modulation. When we talk about modulation, we have something called as M of t. This is message signal, and message signal is actually that signal, the signal which we are trying to transmit. Message signal is that signal which we are trying to transmit, or which is the targeted signal that should reach the destination. There is another signal called as C of t, which happens to be the carrier signal, which in a way carries the M of t. और इन a way आप कोरिलेशन के लिए समझिए कि आपकी मैसेज सिग्नल जो है वो छुपी होती है किसमें? कैरियर सिग्नल. I repeat, your message signal is preserved, or it is encoded in a way in terms of the carrier signal. So we say that the carrier signal is named as carrier signal because it carries your signal to a different destination. How? By converting your low frequency signal towards a by converting a baseband signal to a band pass signal. This shows good that you have been in the class. So these are some important concepts that we need to know. Now let me assume that my M of t is given as this. Okay, my M of t is given as a signal. This is 0 and this is amplitude, this is the time scale. I'm assuming that my message signal is of a nature that its amplitude increases with time. Now if I have a carrier signal C of t, which is given as something like this, a high frequency carrier. Okay, this is my carrier signal. Say this is A of C and this is the time. Yes, I need to extend it to the negative side also so that you understand. So now combining these two signals, the modulated signal will look like something like this. Because of this part, I will have the positive envelope. Okay? I will have the positive envelope and I will have a negative envelope also. And the modulated signal will look like something like this. Can you see now? What I do is that forget about these two. Forget about these two now. Look at this. What I do is that I transmit this, the signal of this nature. I may transmit the signal of this nature into the free space. It goes to the receiving antenna and there it is demodulated. Now the question to you, can you see the nature of the message signal preserved in this modulated signal? Yes or no? Yes? No. If you say yes, you have to answer how. So think wisely. Can you see the nature of the message signal preserved in this signal or preserved in some parameter of the signal? क्या कैरियर सिग्नल के किसी पैरामीटर में आप मैसेज सिग्नल को देख पा रहे हैं? और can you see some parameter of the message signal wherefrom you can decode it what the message signal was? Okay. What I mean to say, if I give you just this signal, you are a demodulator. Okay. Imagine that you are a demodulator. I give you this signal. Can you use some mechanism to actually identify the original signal? If yes, tell me what mechanism you will be using. Can you answer? Yes, you can. Shabash. Give it a try. सही हो आप बता ना. Excellent, that is right. You listen to him. अच्छा आप बताइए. क्या? No, I think his answer is more appropriate. आप फिर से बताओ क्या कहा आपने? किस वेव की? हाँ? Message. See, imagine that you are a demodulator and you set a parameter that any value above the zero value where the peak of this wave, I see the peak of the wave, I take those points and then maybe make this graph continuous. What I will get is, and then I make this graph continuous, so I got the original message signal that. You get my point? So message signal कैसे छुपेगी किसी carrier में? It will be preserved in some parameter of the carrier signal. So that means by modulation, I repeat, therefore by modulation we actually vary some of the parameter of the carrier wave such that the message signal is transferred. आपको समझ आया? So हमारी message signal का जो nature था या जो उसकी शक्ल सूरत थी, वो preserve हो गई in the amplitudes of the carrier. ये तो carrier wave है. This wave is FC. That is the carrier wave. अब carrier wave को हमने modulate किया. By the way, modulate हम किसको करते हैं? Carrier wave को. Yes, please note this point. Modulate कौन सी wave होती है? We modulate the carrier wave by the message signal. Okay? We modulate the carrier wave by the message signal. Okay? And to be precise, some parameter of the carrier wave, I repeat, and keep this in your mind, some parameter of the carrier wave is varied in accordance with the message signal amplitude. in accordance with the message signal. Here in this case, amplitude of the carrier is varied with the amplitude of the message signal, right? क्योंकि carrier का amplitude बढ़ रहा है with amplitude of message. And जब demodulator ने इसको देखा, उसने identify किया ये तो peak points मुझे है, carrier के peak points का amplitude vary हो रहा है. So let me first decode them. उन points को लिया, फिर उसको continuous बनाया, मुझे अपना message signal मिल गया. So here we will stop and we will start with the basic first heading of our syllabus actually, that is the amplitude modulation where we were supposed to start. We can stop here.